Hello, everyone. Welcome to STG-218-S.
Hi, everyone. Welcome and thank you for joining us today. A quick question before we actually move on. In this room, how much of you have a gym membership or had a gym membership in like past couple of years? Thank you. So I have one as well, right? I have one that is pretty expensive. It offers so much stuff like, weights, a swimming pool. I can go to Pilates, and you name it. A lot of different cool activities out there. But even in a good day where I actually go to the gym, I barely use all of these services that I actually pay for, right? And for me, if the gym can offer me something like, a pay-as-you-go model, like pay exactly for the services you actually utilize this month, I think it would be sort of a no-brainer value proposition for a couch potato like me. And this is actually what's so beautiful about AWS and the cloud. What AWS allows us, and Ryan basically touched upon this, is to be able to provision the resources while we actually need and consume them, right? But we also can give all of these resources back when we no longer utilize them. And this is what basically I love about AWS. So my name is Alexey. I'm a CTO and the co-founder of Zesty. I'm 100% not the right guy to solve the business model of gyms, right? But we're going to talk in this session how thousands of organizations across the globe use Zesty to optimize their storage infrastructure and basically increase their efficiency and save cost. So as an engineer myself, I always felt like I live sort of in a triangle, right? We're constantly trying to chase for the perfect balance between stability, performance, and cost. So to be honest, in a real-life scenario, probably we'll achieve only two of these goals, right? Because what we tend to do in production, especially in production workloads, we tend to take a very large headroom. We over-provision our volumes in order to make sure that in any case, in any spike, in any unpredictable event, we have enough storage to basically guarantee the reliability and stability of our systems. The same actually goes with performance, with IOPS and throughput. We, most of the time, provision much more than we need, even if it's rarely used. And basically, no matter how we play this, it's purely human impossible to achieve all of these goals and be efficient in scale when there is thousands of EBS, thousands of EC2 instances, and driven by EBS that we have across the board in different environments. But not only that, when we actually use an EBS volume and when we provision it, we don't have this utilization metric. We just know exactly what type of a drive, right? We know if it's a hard drive, it's a GP2, GP3, and IO1. We know the type of a disk. We know the region that we are provisioning the disk. But in terms of the capacity and how much it's actually used, we basically have to deploy a sophisticated monitoring system and have them in place in order to raise a red flag in case we're approaching a threshold of like 80, 85%, whatever makes sense to us to be able to react. And basically what monitoring systems will probably not tell you is when the EBS volume is somewhere around 5, 10, 20%. There is no risk, basically, so you will not get any alert on this, right? And if you think about my analogy with the gym, right, it's like hiring a lifeguard 24/7 even when the pool is empty, right? And basically, if we take a closer look at what we see on the markets, we see that in most cases, the average utilization for EBS volumes is somewhere around 30%, which basically leaves us with almost 70% of the storage that we provision and we pay for completely unutilized. And to be honest, I really think we can do much, much, much better than this. So what if we can basically create a smart enough infrastructure, storage infrastructure, that will be intelligent enough, predictive enough, and automated in order to adjust the storage and adjust our storage infrastructure to the actual consumption of our applications and systems that are using these volumes. And as you might imagine, that's what Zesty actually built and brought this vision to reality. And if this sounds too good to be true, right? And for folks that are interested to hear how these things works behind the scenes and what makes this solution such flexible and autonomous, let's talk for a second about how we basically manage EBS volumes today. So here is an example, right? We come up with a number. Let's say in this example, it's a 500 gigabyte drive, right? So the only thing that AWS allows us and the cloud provider allows us to do is to only increase the size of this volume. But there is no option to make it smaller. And there is a good technical reason for that. Basically, when we provision an EBS volume, we buy blocks. That's what we buy, right? The file system that is responsible for managing the data and the files that we're storing within this EBS volume is responsible to utilize this variety of blocks. And our data will be probably written in a random manner across the entire block that we have. So basically, there is no way to ask AWS, guys, I want to cut this by half. The result will be we'll just actually corrupt our data or even completely lose it. But also, if you want to make the disk bigger, and there is an option to modify the volume, and here is the trick. You can modify the volume only once per 6 hours. So measure twice and cut once, right? Because there is no way to go back and regret, and also you can't basically grow it in a very small chunks. And basically what Zesty does is that behind the scenes, Zesty will provision a plurality of, and basically take a couple of EBS volumes and combine them together into a virtual volume. So by doing this, we basically allow to have this flexibility of scaling the storage. A good analogy would be, an auto-scaling group of EC2 machines, but this is happening on an instance level. Now, if you think about this, if there is an increase in usage, right, and we need more storage to provision, Zesty can use a simple IAM role, a simple API call, and go ahead and provision yet another volume, attach it to an existing instance, and extend our file system. While the opposite is completely true. In case there is a reduction and we no longer need all of this storage that we provisioned, Zesty incorporates a copy and write technique. So what it means is, in case there is a reduction and we basically don't need the space, what Zesty will do is we will identify there are still any blocks, in case there are any blocks left on the device that we want to detach. We'll seamlessly, using this copy and write technique, relocate them to the other EBS volumes that are here to stay, and make sure there is no data, no blocks left behind, and safely detach this volume and shrink the file system, right? And all of this happening in real time, completely seamless to the application or any kind of workload that is utilizing the storage. Because, as I mentioned, what really matters is the file system. That's our sort of interface to interact with the storage and store and read files. So I think there is still quite a lot of questions around how this looks like in the real world, right? In terms of security, how secure this solution is. Will this complicate the setup in any way? So here is the thing, right? Zesty is not here to replace the EBS or offer any sort of alternative solution. What we do is we utilize the native EBS volumes exactly like you do today. We provision them in your own account. So you're still the sole owner of the data. You still use your standard encryption, KMS, whatever option you're using. And it's all benefiting from the existing EBS infrastructure, which is super reliable and resilient behind the scenes. And basically, the only thing that Zesty is interested in is the utilization metrics, right? We're completely agnostic to the data, to the use case, or the application that is running there. We just want to know and collect the capacity, the read and write IOPS, and throughput to understand what was the utilization. And our backend actually takes these parameters and in real time make a decision and use an IAM role to manipulate this storage blocks. So another interesting question that many customers ask us, how this will basically work with infrastructure as code templates, like Terraform, CloudFormation, whatever you're using. And basically, when you think about infrastructure as code tools, they are amazing to track the architecture, the infrastructure, how it's built. It allows us to provision the infrastructure in a very fast and efficient way. But it's our own responsibility, once these resources are provisioned, to adjust the parameters and make sure that, like we said, we're not running out of storage, we have sufficient amount of capacity, and that's exactly where Zesty takes the standard templates to the next level and do all of this thing autonomously behind the scenes. So as a result, our customers actually see an improvement in their service uptimes, and you can completely forget about waking up in the middle of night if there is an alert and your storage is running out of space. Because we reduce the over-provisioning, and we typically see around 50% reduction, sometimes even more, in cost benefits. And basically, we introduce a low maintenance and hands-free approach that takes all of the management of the EBS out of your responsibility. So I think the best way to hear how this solution works in a real-world environment is to hear it firsthand from one of our customers. And I'm thrilled to announce Meghna. She is a director of cloud financial operations at Securonix, and she will be sharing her experience working with Zesty.
Thank you. Thank you, Alexey, for the introduction. And thank you all for attending today. So for those who are not familiar with Securonix, what we do is we develop and market a next-generation cybersecurity product and also an operation management platform. We have our global footprint all over the world, as well as our enterprise customers are spread it across the world. We have AWS region that is hosted, like I would say 17 AWS regions that we have hosted, and the newest one that is UAE, we are over there also. So now if you think about the footprint that we have to manage for our infrastructure is huge, not just one region, but it spreads across the region. Our technical team is basically situated in US and India. So Securonix redefines the threat detection and response for the next generation cloud, hybrid cloud and data-driven enterprise customers. What we do is our Unified Defense SIEM and UEBA platform is powered with the most advanced analytics, which utilizes and also leverages the behavior analytics technology that is pioneered by UEBA technology. To reduce noise, prioritize the high fidelity alerts, and also speed up the response and investigation for cybersecurity threats and insider threats. So in order to provide the real-time analytics to our customer, what we have to do is we have to process huge amount of data. And that data can scale up to 4 million events per second sometime. And with this amount of data to process as well as to store, you can imagine the portion of this cloud spend that we will have in our EBS volume. And that was a big headache for us. So tech stack, right? So what we have is this partner. We partner with our Snowflake and released our newest platform, which is the Unified Defense SIEM platform, which is the best-in-class threat defense, with a SIEM that unifies investigation, threat detection, as well as response. Now think about the speed and the ease at which the analyst can process the data and the threats and investigation if you give them access to 1 year of hot data. On top of it, if you have, say, proactive defense as well as threat as a content, so that as a service, right? So they have hands-on access to the latest threat content all year round. And then the speed of the investigation can speed up so much, right? But in order to provide that real-time analytics, we had to not only process huge amount of data, but our workload was very spiky. Now you can imagine when you have a spiky workload, and in that case, when we went to support the storage requirement, we had only 2 options, right? Our DevOps engineer has to either over-provision or they have to auto-scale. And none of this option was working out for us. It was very expensive for us. As you can see here, what we have on our just application layer, we have provision capacity of 4. And on our search engine, which was biggest one, right? So we had 3.9 petabytes of EBS volumes attached to it, but utilization was only at 50%. If you see EMR, we had 2.5 petabytes of data, but the utilization was at 30%. With an overall average utilization of 40%, every month we had huge hundreds of terabytes of data that was provisioned, but we were never using it. So it was all the dollars going in the drain. That was not the only challenge that we had. If you can imagine, those you are familiar with AWS EMR, right? We use AWS EMR in Securonix to process thousands of Spark applications every single day. And the beauty of AWS EMR is it saves you dollars in a way that whenever your workload increases, it speeds up and spins up your nodes. Whenever the workload goes down, the node comes down, right? That's beautiful. That saves the dollars. But we needed a solution that can provide and manage our storage not only on the volumes that are the EC2 instances that are static, but also on the ones that are scaling up and down. So when we set up our part to find a solution that can resolve our cost optimization on the EBS volume, the criteria was very simple. We wanted a seamless solution that is easy to deploy, that can save us dollars, and also should not create any service impact on our environments. So when you see, This one, okay. As I've already talked about, right, our average utilization on our EBS volumes was about 40%. That's why the cost criteria was the biggest one for us. We set our benchmarking at 25% cost savings, which was easy to gain, right, because we had only 40% utilization. That was not the only part that we were looking for. Cost savings always has two parts to it, right? One is the infrastructure cost optimization, and another part is the operational cost. We will never wanted a solution that we have to put in extra operational hours in order to maintain the solution. So, because that is additional cost for us, right? So those were the two criteria for the cost. Then service availability and uptime. We wanted a solution that would never hinder our service availability and the SLAs that we were meeting at that time. Then comes low efforts of deployment and maintenance. Everybody needs that, right? Any solution that we do, we don't want a complex deployment of the solution. So for us, it has to be a seamless automation that we can deploy the product in our existing stack. And plus, we did not wanted a product that we had to babysit all the time. That's additional operational cost. We were not ready to take it. And the last but not least, we needed a solution that is enterprise grade, that is highly resilient, scalable, and secure. With this criteria in mind, when we try to look for a solution, trust me, there are not that many solutions out there that can solve both of our problems. But when we evaluated Zesty not only met those criteria, but exceeded those criteria for us. And let's see how. So this is the EMR. When we deployed the solution, we started with our application layer. Reason being, we had the least amount of storage on it, right? Only terabytes that we had to deal with. But the issue with layer is, if there is any service impact or service failure on the disk, the impact was huge for us. Because it's a user interface that right away the customer will know there is a service degradation, right? We had HA enabled on our application, so we were covered. But what additional provision we want and precautions we did is we added the buffer to it. And what Zesty does is it can serve you based on your risk appetite. What I mean by risk appetite is that you can have a fixed buffer on top of what your provision storage would be. You have an utilization, you can add a fixed buffer. So your provision storage would never come below that fixed buffer. So we added our buffer and we went to 30%. Yes, it impacted our cost savings, but service availability is also important for us, right? So that is the beauty of Zesty, that you can maneuver it however you want. Within a month, we rolled out Zesty Disk on the entire fleet of our application layers successfully, no issues whatsoever. Then came our storage. Storage, as you can see, we had 3.9 petabytes of data on it and only 50% utilized. In this case, we did not tweak the buffer. We wanted Zesty to do its job and save us dollars because the cost optimization was also a big deal for us. And Zesty did that. It delivered us, without the service degradation, the cost savings that we were expecting. Then came EMR. We released EMR also. EMR, as you know, that the nodes were going up and down. Zesty's engineering team worked with Securonix to develop the custom AMI in order to ensure that when the nodes goes up, we have the disk attached to it. So let's look at the results, the final, right? What you see in the graph below is the 1 month performance of Zesty Disk Securonix environment. As you can see, the blue area that you see over here is our usage. As I said, it's spiky. This is the one of the environment which was not that spiky, but you can see a little bit of a spike in there. Then comes the yellow line that you see up there is the Zesty provision disk. As you can see, the gap between the usage and the provision disk. This is very critical, right? Because as the gap goes up, your cost saving is going to get impacted. But as the gap is very little, you're going to get service degradation in there. But as you can see, over the entire month of the utilization, Zesty was following the path of our workload. And it was increasing and decreasing based on our workload. One of the day in that month, as you can see the huge spike in there, right? What would have happened before pre-Zesty? Our automation scripts would have kicked in. Our provision storage would have kicked in at that level to serve our performance. But then, when the spike subsides, what happens? Stays at that level till somebody in our operations team goes in and manually detaches and makes sure the changes has happened and the disk is detached. It's not difficult. It's not difficult to maintain your utilization in EBS volume manually. But the most frustrating thing is you make the change one day, the next day, the utilization starts going up. So it's a complete cycle that you have to keep on going back and forth. But post-Zesty, if you look the beauty of it, when the spike happened, the provision storage goes up. When the spike is dissolved, the provision storage comes down, and you are back to normal. And that was very critical for us, right? Because as you know, our workload was very spiky. Now, if you see the results, in 6 months of deployment in just these 3 stacks, what we have reduced is our disk size from 6.8 petabyte to 3.15 petabytes. Our provision storage has gone down by 50%. And our utilization of our EBS volume has gone up from 40% all the way to 80%. In all, 3 of them, what it has done together is given us 200K of a monthly cost savings on just EBS volume disks. And that's not it, right? As I said before, there is always 2 factors for cost savings. There's always an infra side of it, and there is an operational side of it. During this 6 months, hardly we have received any disk failure alerts. So you can imagine where we had all those alerts where our team was constantly chasing the provision storage. Now we have no cost on that operational hours. On top of it, whenever there is any disk failure even happen, it was Zesty's team talking to us like, hey, we have a disk failure, we are looking into it. So this is a kind of the partnership that we had with Zesty. And that was beautiful, right? We saved dollars on the operational hours too. And not just that. We watched this pattern for 3 months on our CloudWatch alerts. As we were not getting any alerts, after 3 months, we could even save on our CloudWatch alerts cost. So it's not just the Zesty can save you dollars on the disk, it saved us dollars on the operational cost as well as on our alerting cost. So it's a combination of all 3 of them. This is the snapshot of what our disk was. As you can see, the pre-Zesty in all these 3 layers and the post-Zesty provision storage. And you can look at it, the utilization level. Before, when it was ranging about 30 to 50% max, it has gone up to 75 to 80%. On top of it, no service degradation. That was very critical for us. Being a cybersecurity company, we were really strict on our customer data. We cannot have any loopholes in any solution that can compromise our customer data. But with Zesty, we never had that issue. With that kind of success that we had in the 3 layers of our Zesty rollout, this month we have also started the rollout of Zesty on our biggest layer, that is ingestion, where we use Kafka. And we are looking for the same level of optimization and the cost savings in that layer as well. So I'll end this thing just with one note, right? The core advantage of Zesty Disk is not just to provide one-time cost saving. Solution out there can do that, right? But what you want as in FinOps and cost optimization, that you can get that cost savings month over month without any operational overhead. So with Zesty, what we achieved is we deployed Zesty, and it just does its work. There's no operational overhead. There is no service degradation. We get the cost saving that we need. And life is beautiful, right? Because this is what you need from a solution when you're looking for it. So with this, I'll say it was a pleasure working with Zesty team, Alexey, and we are looking forward to what Zesty has next.
Thank you so much. Thank you, Meghna. It was a pleasure to hear the feedback. It's not obvious to have you here on stage with us. Thank you. And actually, Meghna already touched upon some of the use case, right? We spoke about Kafka, EMR. Basically, Zesty has a support for native AWS services, a variety of them. It's AWS batch. Think about batch jobs where you have a queue of tasks and a lot of worker nodes, right? Everyone receives a different task. We have use cases like AI and machine learning customers that are using this solution with AWS Batch. Now, think about when you have a queue of tasks, and we have a customer that is running hundreds of thousands of EC2 instances concurrently to train their AI models based on videos that they're in the automotive industry, so they have to process all of these videos that they recorded from the vehicles. And think about a vehicle that has a very short drive, or a vehicle that is driving from London to Paris. It's a very large workload that they need to process. So instead of provisioning for the worst case scenario, for the largest workload that they expect to have, and monitor this across the clock, they actually start with a small volume. And as they ingest the video and process it, the disk is growing. When there is another task that is approaching this node, Zesty will actually go and shrink the volume according to exact utilization that is needed at this point of time. So like I said, there is a support for native services like EMR, spot instances, and Meghna touched upon the fact that if you have workloads that are going up and down, like spots, like EMR that is scaling up and down, so we support any kind of use cases and databases that are running for a long time as well. So I think I would like to take the opportunity being here to announce a very cool feature that's basically driving the enterprise-grade storage experience to EBS volumes, and this is a compression. Now, when we talked about Zesty Disk, we were always talking about shrinking and extending the actual infrastructure, right? And we spoke how Zesty can adjust the volume size underneath, but we haven't spoke about the data. So that's what makes this announcement exciting to me. So using compression, a well-known compression algorithms out there, Zesty is able to implement them on the storage, on the actual data that you are storing on EBS volumes, and drive even better cost savings, which is in particular cases can go up to extra 40% of storage footprint reduction. We also integrated Zesty Disk with AWS Marketplace in order to streamline the payment and usage of the product. So Zesty Disk becomes just another line in your AWS bill. So please let me wrap up. When we look at the long run, right, at scale and into the future, our goal should be pay less, sleep well, and provide the best service for our customers. We must remember that it's no longer an option but a necessity to incorporate an automated and predictive AI and tools that can drive efficiency of our cloud and be available there 24/7. So we saw how Zesty Disk is able to eliminate the over-provisioning of our storage, reduce the footprint of our constantly growing data, and the ease of implementation and integration that we basically allow. So I invite you to think about the three following questions. First, what's your utilization of the EBS volumes in your organization? How efficient you are? Do you feel like you bleed money? And how much it would cost you to go and fix all of this manually? And what it will mean for you if you can automate this and fix this automatically. So I think it's a great time to rethink our attitude to cost optimization and performance in our cloud environments. And I think if you have any more questions and stuff that we haven't touched in this presentation, we're here. And also, we invite you to come to our booth number 474. And we thank you for the time, and have a great reInvent ahead. Thank you.